All right, this will be the section of notes, the video lesson for Chapter 11, Section 4. And we're going to transition away from surface area and into volume. The simplest volume calculation will be a square prism, also called a cube. So assuming this is a square in every dimension, oops, then you can see how, I'm not doing a great job of drawing this one, but you can see how you would have length, width, and height. And a square cube, because all of the sides are the same amount, the volume is equal to side cubed, length times width times height, or the actual side times side times side, since all the sides are the same. So keep in mind with all volume calculations, you're going to need to make sure that your answers are cubed. It should show up on Math Excel as well. I don't think it'll be that big of an issue. So that leads us, first of all, into Cavalieri's principle. Cavalieri's principle is fairly simple. It's something you should at least make a note of. It may show up a little bit on a test, although it might just be one that you have to use. But if you've got two figures in a space that have the same height and the same cross-sectional area at every level, then they must have the same volume. I would check page 718 and look at the picture to try to understand why that is. It's too hard to explain via a video lesson without you actually staring at that picture, so just look over it. And that leads us to our volume of any type of a prism. Now, the easiest prism for me to draw is always going to be a rectangular prism, which is what I had just had earlier. So there's my rectangular prism real shortly. But this can be a triangular prism too. You can have a triangular base like this. Actually, that needs to be seen for at least part of it. And there you can get an example. I've got that one a little bit messed up. You could have a pentagonal prism and all other types. But whatever type of prism that you get, just remember that the formula, the volume, is the base times the height. Now, that seems fairly simple, just two things. The problem is that base varies. If you're talking about the base of a rectangular prism, well, that's length times width, and so you would say length times width times height. But if you're talking about a triangular base, it'd be 1/2 base times, well, I got to get a B, H, times the other height. Then you can see how those two heights can get mixed up. One is the height of the triangle. The other is the height of the prism. So be careful there. And then if you go even further, if you had a regular pentagon as a base, then it'd be 1/2 PA times the height. So again, that base is variable as needed. But again, I think we've done enough with all of our area calculations that we're just adding one extra part to it. Shouldn't be too hard. I'm going to leave you to look at the examples in the book on finding volume of prisms, because I think they're fairly self-explanatory. You just have to see what you're looking at. The difficulty being figuring out the area of the bases, which goes all the way back to our Chapter 11 knowledge, especially with triangles. And you can see on problem number 2 in the book on page 719, if you'll look at it, you have a triangular based prism. And that prism can be a little bit difficult to figure out because you've got to figure out the height of that triangular base. And it's an 8 by 8, and then the base of the triangle itself is unknown. So you've got to figure out that last little piece of that height. I think the problem does a good job of describing it, so please look at that one. Instead, let's go into a cylinder. Similar to when we were doing surface area in 2 dimensions, the volume of a cylinder is really pretty much the same as the volume of a prism. The only differences are that the bases are circles. Because of that, instead of the volume being base times height, we'll go ahead and take the base out and replace it with pi r squared h. The base being a circle, the area of a circle being pi r squared. So you're going to need to figure out a diameter or a radius. So you can take half of the diameter or something similar and the height of a cylinder to find the volume. Again, the book has some examples there that I want to turn you towards because I don't want to inundate you with a lot of time on this. Instead, I'm going to ask you to come into tutoring where I can deal with individual problems and help you sort through where all of the values of the height or the radius or other things can be found. As always, please watch out for composite figures. Trace them on your computer if need be, and break them into the various pieces that are necessary for that shape. Let me check and see how much time I've got on this video lesson first. Still got plenty of time, so I'll do one composite shape. Problem number 4 on page 720. These composite shapes are the difficult parts. There basically is a rectangular prism, like so. Get that a little bit too far down. But one problem with this prism is at the end of it, it's got half of a cylinder, which is very similar to what we had on the last one. Having a little bit of a difficulty getting it drawn. There we go. Okay, so here's what I want you to do for any type of compound shapes. I want you to put the volume of the figure, in this case I think it's a fish aquarium, is equal to the volume of the prism plus the volume of half a cylinder. If you'll write it out like that and let yourself see what's actually being combined all together, I think it's going to help you, because then we could do the volume of the prism is length times width times height plus 1/2 of pi r squared h. And then all we have to do at that point is fill in everything. The length times the width times the height on the prism is 24 times 36 times 24 plus 1/2 of our radius on this particular one looks like it's 12. So it's pi times 12 squared. That's a 12 there. It's kind of hard to see. Times the overall height, and the height is 24, again, because the height is the same as the prism. And then it's just a matter of doing some math and estimating correctly. This is how I want you to do compound or composite figures. there's still a lot of possibilities for mistakes or errors and things like that. But if you go slow and you write it all out, I don't think you'll have a huge problem. All right, so there's a brief lesson of chapter 11, section 4 on volume. 11.5 will just be volume of, just like this is prisms and cylinders. We'll have pyramids and cones and their volumes, which are similar. All right, and then be sure and join me for any tutoring sessions that you need some help on. Some of these problems can get a little tough. Hope y'all had a good weekend. I'll talk to you soon.